Now let's talk about shielding effect. What is shielding effect? In today's tutorial we will discuss about shielding effect. So shielding effect is the reduction in the force of attraction between nucleus and the valence electrons by the electrons present in the inner subshells is shielding effect. So as you know, this is the nucleus where you find positive charged particles called protons. So if these are protons and this is the nucleus, so this is the positive charge nuclei of an atom, and the shielding effect is that phenomenon in which the force of attraction is reduced by the electrons present in the inner subshells. So this is the shell of this atom. This is another shell, this atom, another shell of this atom. So as far as the shielding effect is concerned, it is the reduction in the force of attraction between the nucleus. So this is the electron having negative charge. This negative charged electrons are attracted by this positive nuclei or the nucleus of this atom. So here you will find more electrons. These shells also contain electrons, as you know. This shell contains electrons. So this is the reduction in this force. Like these are also negative charge as they are electrons too. So shielding effect is that force which is applied by these electrons, the repelling force through which these electrons repel, because negative and negative charges repel each other. So this electron is attracted by this positive nuclei, but what happens is these electrons shield this nuclei. How? It reduces their force of attraction between these two, the valence electron and the positive nuclei. So there are trends in this periodic table. You will find trends like it increases from top to bottom in a group. If this is the group, you know that hydrogen is on the top of this group, and here you will find another element, like let's say it is magnesium, which are not in this group, but just to make the point clear, this positive charge nuclei of hydrogen will attract its outer electron, its outermost valence electron, but they will be shielded by these electrons, repelled by these electrons. Their force will be reduced by these valence shell electrons. And this reduction in the force of attraction between the nuclei and the electrons is called the shielding effect. It increases as you move from top to bottom. So if you move from top to bottom, what happens is that you increase shells to the atom. So as many as shells are there, there will be that much more electrons, and all those electrons will reduce collectively the force of attraction between the valence electron and the positive nuclei. As you move from left to right in a period, these are period, the horizontal rows are the periods. So if you move from left to right, like this is the left side and this is the right side. So if you move from the left to the right, the shielding effect remains constant. These two trends. You must remember these two trends, and you will have to write down these trends if they ask you in exam that what are the trends of shielding effect. So why this shielding effect remains constant as you move from left to right in a period? Because as you move from left to right, you only increase number of electrons in the shells, right? So sorry, the number of shells are not increased, but the electron numbers are increased. So the free shielding effect is produced by the repelling force of the valence electron, these subshells, and the reduction is due to these subshells. So if you are not increasing subshell, you are not increasing shielding effect. That is the thing, because in the first shell you will find that there are two electrons. According to the formula 2n square, there will always be two electrons. So no matter how much you move from left to right, you will not change these electrons. Like this shell will always contain two electrons. That is why it remains constant and the shielding effect remains constant. Let me repeat this whole shielding effect again. The reduction in the force of attraction between nucleus and the valence electron by the electrons present in the inner subshells is shielding effect. The trends, it increases from top to bottom in a group, because from top to bottom in a group, as you move from top to bottom, you increase number of shell, which means you increase number of electrons, and those number of electrons are forcing this force of attraction between the two to reduce. And as you move from left to right in a period, the horizontal rows of the periodic table, as you move from left to right, the number of electrons in the shell remains constant, so the force of reduction by those electrons is also remain constant. Hope this makes sense. See you in the next video. Take care. Allah Hafiz.